Hi everybody, this is Jason and a happy Friday to you. I've been doing a lot of reading this last couple of days about the 2019 novel coronavirus outbreak, and I thought I'd share some of that stuff on YouTube for friends and family. Anybody else who's interested. Hopefully it's not too technical. I got the information from a couple of main sources, from the World Health Organization and from the European CDC. I don't tend to watch TV news or read a lot of newspapers, so I get most of my information from the internet. So that's just where I got this information. And for those of you who are wondering why this particular subject, it's kind of my background. I was trained in science. I was a virologist working with respiratory viruses in the past, in the old days, good old days. And I don't know, it's something that's kind of dear to my heart. And so because it's in the news, I thought I'd have a chat about it. So how did we get where we are today with the outbreak? Well, some of you will probably remember on December the 8th, a cluster of 27 cases of pneumonia were discovered in Wuhan in China, in the Hubei province. They seem to be clustered around an open-air seafood and livestock market, and the patients presented initially with a severe respiratory infection, some of them very quickly developing acute respiratory distress syndrome, which is ARDS, and other serious complications. The Chinese, I think, got onto it fairly quickly. By about the 7th of January, they'd isolated and identified the novel coronavirus, and by the 10th, a couple of days later, they'd fully sequenced the genome and started to share it internationally with scientists working all over the world. Very shortly after that, the World Health Organization named this virus the 2019 novel coronavirus, and then on the 30th of January, yesterday, WHO finally declared a public health emergency of international concern, and that kind of ramped things up from an international point of view and helps focus the attention of governments and national bodies on making sure that we limit this outbreak as much as possible. As well as the World Health Organization becoming increasingly interested in this outbreak, particularly as it spreads outside of China, I think they feel that it's probably fairly contained in China. They're pretty happy with what the Chinese government have been doing, but they're increasingly worried the more countries it spreads to, the more of a potential problem it can be. And I think what they want to try to do is make sure that the governments are focused as much as possible on limiting the spread by various different methods. And if you just have to look on social media and listen to the what's going on the internet and the news reports and things, and you can see that people are very concerned in the general public as well. Events are moving very, very rapidly, and it's still very early days in the epidemic. But one of the real problems with this kind of thing is that this virus is essentially new. And the problem with emerging viruses is that because they've just been newly transmitted from an animal to a human host, and we think in this case it might be bats, although it's very early days to really conclude that. Since it's very new, we simply can't and don't know very much about it. As I say, things are moving very quickly. We're finding new things all the time. But basically what needs to happen is, as well as the research being done to find out all the information we need to know about the virus and how it spreads and everything, the government can't wait and hold back and before it makes policy. So they kind of have to leap before they look. They kind of have to make policy before they really know that much about actually what's going on. That's not really their fault. That's just the nature of the thing. And everybody obviously worries that the new thing is going to be worse than the old things. The old things in this case being SARS and MERS, which are the things which are most similar to this current outbreak. So we can't really wait until we act. So while scientists are finding out the facts, the government is acting to implement policies to mitigate the impact and spread of the disease. So, whilst the World Health Organization is monitoring the epidemiology of the outbreak to come up with the best advice to governments, and while governments are creating policies based on kind of a worst-case scenario, they're trying to limit the spread of the virus as much as possible, imagining the worst, imagining it spreads and it's very infectious. Scientists are trying to work out the answers to the top questions, really. What about this virus? How does it work? How infective is it? What mode of transmission is it? Where did it come from? How long is the incubation period, etc.? So just going through these points one at a time. Infectivity, or how infectious it is kind of how many virus particles essentially it takes to give you an infection. So, is it just a matter of going in a room or passing an open door in a room, or do you have to be with a patient for a very long period of time before you get enough exposure to the virus before you get an infection? Or what's the mode of transmission? Is it, as we suspect, a respiratory, in other words, from small aerosols which are expelled during coughing and normal breathing from the lungs with virus particles in it? Or is it contact or body fluids or something else? Or it could be animal bites, not in this case it seems. Where did it come from? So at the moment, the most likely animal is bats, although that's certainly not confirmed. Really, we still don't know, but bats is actually a likely one. There's been all kinds of stuff going around on the internet about people eating bats in China and all this other stuff. There's no real evidence that that's the problem, but there've been a couple of studies recently, both in China, one in Wuhan, one in Beijing, where they looked at the viral RNA sequences of viruses extracted from patients with the disease from early in the epidemic and fairly recently in the two different studies, and they found about a 88 to 96% similarity between the viruses they find in the patients and the viruses they find in bat coronaviruses. It's about 80%, 80 to 87, well, about 80% similar to SARS and about 50% similar to MERS. So it's not SARS or MERS, but it's like it, but it seems to be most similar to bat. So maybe the bat is the reservoir where it came from originally, but it's still not finally determined. How long is the incubation period? The incubation period is extremely important. A long incubation period might be a bit of a problem because it allows people who have been infected but not yet symptomatic to move around and escape the quarantine areas or escape detection and then pass it on. Particularly if infected people are infectious before they have symptoms. So whether they're infectious before or after they have symptoms, how long the incubation period, this is very important for gaining an idea of how quickly the epidemic is likely to spread. We're starting to get these ideas now, actually. Also, how many infected versus infectious people are there? Should we be screening everybody, not just those with severe illness? Again, that's relevant to those other 2 points I've just mentioned. So if people are infectious when they're asymptomatic, maybe we need to be screening everybody. So we need to find that out. How severe is the disease that's caused, and what determines the severity of disease? At the end of this little presentation, I've got some information from a very recent study that was published yesterday, giving us some insights into that. And of course, something that's of very great importance to most people who know about this: what is the mortality rate? Again, we're getting indications of that, but we don't know enough really to be very certain. On the face of it, it appears to be a bit more infectious than SARS, but a little bit less pathogenic. In other words, causing less disease than SARS, but spreading a bit quicker than we would expect for SARS. So here are a couple of pictures of the critters. What they actually look like. So the photograph on the left is an electron micrograph of actually SARS virus, not novel coronavirus. It's more or less the same thing. You can see this has been enhanced by colours, but it's just like a blob with a load of spikes on. On the right hand side you see an artist's impression, which is kind of exaggerated version of the thing on the left. This is just a drawing or a graphic of what it looks like. So it's a blob with some spikes. They call it coronavirus because it has the appearance of a crown. So those spikes with the blobs on the end look a little bit like a crown. So I just want to get very briefly into a little delve into the biology of coronaviruses. It's quite a large family of viruses that infects humans and other animals, mainly other animals actually. About 40 different species, 4 of them very common cause of mild cold and flu symptoms in humans. So if you've had a few colds in your life and you're as old as I am, you've probably been infected by a coronavirus already at one time or another. Obviously a different virus to SARS, MERS or the 2019 novel coronavirus, but you may well have had one. Most common colds are caused by rhinoviruses, but coronaviruses and lots of others can also cause it as well. So you may well have had one. The 2 recent discovered, now infamous, obviously SARS and MERS. And SARS was originally transmitted to humans from civet cats, and MERS sort of have been transmitted to humans from dromedaries. We're still trying to work out how the current viral outbreak originated, but it may well be bats. And a novel or a new coronavirus is referred to as an nCoV, or a novel coronavirus. Hence, this new virus has been imaginatively named 2019 novel coronavirus by World Health Organization. Kind of hope that they come up with a better name than that. It doesn't really roll off the tongue. And the RNA sequence from the current strain is different from the 6 other coronaviruses, subtypes that infect humans, but it has been classified as a beta coronavirus. And here you can see a little drawing of, a diagram of the actual structure of the virus. And this is beyond what most people are really that interested in, but just to say that the little red twirly bit in the middle is where the RNA or the nucleic acid is, and that's surrounded by a protein. Then there's a viral envelope and a number of proteins stuck in the outside. Those proteins that stick around the outside are what helps the virus stick onto your cells and get into your body or into your cells and cause an infection. Without those proteins, it can't get in. So that's just a little look at the virus. So on to a discussion of how the epidemic is progressing from an epidemiological point of view. So we have 9,836 confirmed cases so far, 99% of them in China, in the Hubei province, in fact close to the original town or where they first found the virus. 213 fatalities, unfortunately, all of those so far in China, 96% of them in Hubei province itself. So most of the cases, most of the fatalities are more or less clustered still around the place where the infection first arose. Obviously, we all know that it's spreading around the world. About 12 T1 countries outside China now have cases, including 2 cases in the UK reported today. And this is the 31st of January 2020 that I'm recording this video. Also, just worth pointing out that these figures are subject to collection errors, so we don't know exactly whether these are the exact numbers. This is the best numbers that we've got so far. So this first diagram is showing you the locations of all the viral outbreaks or the cases of the virus as of yesterday. This next one, the second one, is showing you a kind of a graphic interpretation of where the cases are. So a great big blob for China and tiny little blobs for everywhere else, which you've only got a handful of cases at the most. And so all the cases are in China, as I said before, and all the deaths as well in China. Just for reference, SARS, there were in total throughout the whole epidemic, there were just over 8,000 infected cases, but 774 official deaths. So just looking at those figures, it makes it look as if SARS was a little bit more deadly, but less infectious than the novel coronavirus that we're dealing with at the moment. And then we have a look at this next graphic, and this is essentially showing the number of cases, the total number of cases reported on a daily basis. So as you can see, right back on the 9th of January, we're right down at very few cases, and then coming up, it started to really go up from the 19th, 21st of January onwards, till where we are today on the right-hand side of that graph with 31st of January. I've provided the link there where you can get that. This is on the European CDC website, which is really good for this current information. Looks to me, looking at that graph, as if it exploded, and then from the 28th of January till about now, so for the last 3 or 4 days, it seems to have plateaued a little bit. Now, that might be far too early to make a conclusion like that. I'm sure professionals working in the field today are not going to make a conclusion like that. But to me, either that is an aberrant result on the 28th of January and the 29th of January, or it seems to have shot up and then peaked a little bit. Now, that would be very good news if that's what's happened. That would indicate that the measures that governments are taking have helped limit the spread of the virus, and that there's going to still be new cases, and unfortunately there's still going to be people who die from this. The numbers are going to increase over the next weeks. But I'd really like to think that looked like that was the first indication that maybe we're getting to grips with it. Maybe I'm just jumping the gun a bit there, but I kind of like to be a little bit hopeful looking at these results. Down to what the government's managed to do with their policies. But there's another point that I just want to make as well, is that respiratory infections are very, very common. Everybody's getting very worried at the moment. I'm sure there are people who are thinking, I've got a cough, I've got a fever, maybe I've got SARS, maybe I've got novel coronavirus. Well, I just want to make the point that the vast majority of people who get fever and cough or other respiratory symptoms today most likely have either a cold or flu, especially if you're this time of year in the northern hemisphere, because it's winter. So it's the season for colds and flu. So if you've got a cold and flu, it's probably cold and flu. Especially if you haven't been to China or you haven't had contact with returnees from China, particularly in those areas where the infection is concentrated, or if you work in the medical profession treating pneumonia patients, particularly patients who are returning from China or are already infected. Another little bit of perspective as well is that influenza and other viral infections are not that much fun either. So we're all focusing on this one particular virus, rightly so, particularly governments and CDCs all around the world and the WHO. They should be focusing and trying to limit the outbreak of this thing, primarily because we don't really know how bad it can be, so we have to err on the side of caution. But it's worth sparing a thought for the kind of viruses that I used to work on. I did my PhD on influenza. And although the overall mortality rate for an infection like influenza is generally low, about 0.01%, CDC estimates that influenza results in something like 9 to 45 million illnesses This is in the US alone. 140 to 800,000 hospitalizations every year, and between 12 and 61,000 deaths every year. And that's just in the US. They were figures that easily came to mind, which is why I used US figures. And also since mid-December, when the 2019 novel coronavirus was first identified, or when we first saw the pneumonia cases, we didn't know what it was then. Something like 150 people have died from flu in California alone since that day. So I just want to put that in a little bit of perspective. We're all worried about this thing, but as always, there may well be other things that we'd be better spending our time being worried about. Not really trying to diminish the potential importance of this outbreak. It's pretty serious already. We don't want to get it any worse. It might get a lot worse. But there are other things as well to be worried about. So let's try and keep it in proportion. Let the experts worry about it maybe more than worrying about it ourselves. So just talking a little bit now about how it's diagnosed. I think it's kind of interesting that people often imagine that you go to the doctor, you get a diagnosis for viral infection, and it's like it's set in stone that you've definitely got it. So as with many viral and respiratory infections, it's not really possible to diagnose a case of novel coronavirus infection based on symptoms alone, particularly because these symptoms are shared amongst a number of other respiratory diseases. So in essence, a presumed diagnosis is made based on medical history, and as listed below, I'm going to talk about in a second, and then that's confirmed by RT-PCR. RT-PCR is a technique where, based upon the known genetic sequence of the virus, which the Chinese released very early on in the epidemic, they designed a test based on that sequence. You can actually test for the RNA sequences specific to this virus. So we know for certain after we do this test that someone has or hasn't got the virus. So the criteria for diagnosis is the presumption is based on unexplained severe acute respiratory infection, essentially kind of a pneumonia really, and a history of fever and cough requiring admission to hospital. So someone who's really sick, that's got fever, had a fever and cough, and maybe got pneumonia. Shortness of breath is, I've seen that listed in some, but it's only about 30% of patients so far. You'll see that in the subsequent paper. I mean, this is all provisional, but that may not be necessary, but the others are. And also, one of the following is required for a presumed diagnosis. That's history of travel to or a person who lived in Wuhan, Hubei province, China, in the 14 days prior to symptom onset. So you've either been there or you've lived there, or the patient is a healthcare worker working with patients with severe acute respiratory infections, without regard this time to place of residence or history of travel. So you've either been to China, been in contact with people from China, essentially, and you have these symptoms. That's how they diagnose it. And then they do a test which kind of removes all doubt as to what you've got. So I want to move on now to the last two slides. Is to kind of this is what really got me started. I read this paper the other day, and then I wanted to do a video. So this is some of the early epidemiological and clinical characterization of this new coronavirus pneumonia. And this is a study that came out of Wuhan. This was a study of 99 pneumonia patients. These were patients that were admitted between the early January, I think January the 1st and January the 25th, 2020. These were patients in Wuhan. They'd been admitted, they'd been in other hospitals, then they were transferred to a central infectious disease specialist hospital, and then they were treated there and studied there. So half the patients were men, the mean age of about 55.5, so 67% of them were actually over 50. Half of the patients had existing chronic diseases, including cardiovascular, cerebrovascular, endocrine, digestive, respiratory, malignant tumours or nervous system disease. So some of these patients were quite sick already. Half of them worked at the seafood market, and on admission, 80% of them had fever or cough, 30% had shortness of breath, so only a third of them had that shortness of breath diagnostic symptom. And then there were lots of other symptoms, including muscle aches, about 11%, confusion, 9%, headache, sore throat, rhinorrhea. Rhinorrhea is like runny nose, chest pain. So yeah, generalized kind of coldy flu type symptoms. And the patients clearly had fever and cough, but they don't say in the paper how the symptoms clustered in individuals. So they don't say that the ones that were most severely had all those symptoms. They don't really talk about that. So by the end of the study, they studied these patients over a period of time. 31% of the patients had been discharged. I was talking to my daughter, my youngest daughter, the other day, and she was under the impression that nobody had ever been, I'd say, cured in inverted commas. No one ever got over it. People have got over it already. So see, some of these patients who've been in hospital in Wuhan, who've had the infection, they've recovered from it enough to be discharged from hospital. 11% of the patients unfortunately died, and then all the other patients were still in hospital at the end of the trial. So presumably they'll continue the study and then give regular updates in future on how these patients have done. And the more information we get, the more people get sick, unfortunately, the more people that die, the more idea we get of what would happen if somebody was to get it, the more able we'll be to predict the likely course of a sub-epidemic or the course of a particular patient. In general, though, I thought this was interesting. The characteristics of patients who died were essentially older men with comorbidity. In other words, they had other things wrong with them as well. That's not universally true, but most of the cases were in that group. Also, I think it's worth pointing out that all these people had pneumonia and serious illness when they were admitted before they knew what was wrong with them. So they're not looking at people who are either asymptomatic, people who have got very mild symptoms. So presumably there could be people out there who've got mild symptoms, not severe enough to test them for the virus. So, whether that's the case, I don't know, but it's possible, I suppose. It certainly does happen with other infections. So the outcomes were in line with this MULBSTA score, which was an assessment based on history of the patient. So this is multilobular infiltration, which is whether both lungs are involved with pneumonia, hyperlymphocytosis, involvement of their white blood cells, bacterial co-infection. A lot of these patients had bacterial co-infections, whether this were before they got the viral infection or as a secondary pneumonia, we're not quite sure. A lot of them had a smoking history, hypertension, and they were older than 50. So the score. And this score tended to coincide with the outcome of the infection in these patients. So this is why people are now starting to say that it's in older men and people who are already sick. Who knows how that will change a little bit, but it's quite a good study that they've done fairly early. I mean, it was published yesterday in The Lancet, which is the journal of the British Medical Association, so it's quite a respected medical journal. So we'll see how it goes. So I think in terms of the upshot of what I want to say about this, I'm not losing a huge amount of sleep about it. It's obviously serious. We have to keep an eye on it. Governments are doing that. World Health Organization is doing that. I'm reasonably confident that governments are doing more or less everything that they can. And sort of finally, in summary, I just want to emphasize the fact that sort of my assessments and reading of how serious the impact is and whether there might be a little bit of a lag now in the a peaking of the cases in China kind of always depends on how well it's been reported, how well it's been recorded. There is some discussion that maybe China didn't act as early as they could have done in the initial case. I've heard various odd reports of people being arrested for sort of whistleblowing, I guess, in the early stages of the condition. Hopefully that's not true. Hopefully that even if it is true, that they're actually recording correct numbers now, and hopefully everybody's doing their best to make sure that the figures are accurate and that we're getting a good picture of the epidemiology these days. So I just want to say have a good weekend, have a good Friday, have a good weekend, and hopefully I haven't upset anyone or put anyone off. If you like what I've been doing, give me a comment, and that will either encourage me or discourage me depending on what you say. So see you later and have a great weekend.